Welcome to the last video of the semester. Hooray, we're almost done. Last video I gave you just about all the main notes that you need for chapter 9 and chapter 10. Actually, I did give you all the notes concerning certain topics, BS8, etc., etc. And what we're getting ready to do now is we're going to take all those things and we're going to put them together. Okay? Now, the one thing that I did not cover last time was that equation D over H times Q equals X. We're going to be talking about that in this video. However, as you can see in your printed notes, all you have is, what, 10 questions. You have 10 questions here. You don't have anything else with it. So you are required to print these off. You are also required to have on another sheet of paper your work for these questions. All right, that's how you're going to be taking your notes today. There's no guided notes on this one. We're just doing 10 straight problems. We'll get right to the point. Okay, and the other thing that you need to make sure you have is your formula sheet, because we're going to use a DH over Q times, D over H times Q equals X. We're going to be using that. I'm going to be talking about what that's about, and I'm going to be referencing your formula sheet on it. So if you don't have that, get it. Also, there's a problem that's going to require you to remember King Henry all the way back from Module 1. Just be aware of that. And that's pretty much all the little things that I want to talk about what to expect in this particular video. So, before you go on, make sure you got these 10 questions printed out. Make sure you've got something else you can write on to do your work, because you're going to need it. And 2, make sure you have your formula sheets and kind of remember King Henry a little bit. Alright, and have a calculator. Now, it goes without saying, I do not feel like saying pause the video, pause the video, pause the video, pause the video, pause this video, all through this video. Please pause the video when you need to. When I start to do a problem, I might say, try this on your own, and then I'm going to keep on trucking. Alright, when I say try this on your own, please pause the video and try it on your own. Okay, I'm hoping that you will do that. Okay, don't just write everything I say. Okay. Alright, so that's all that little junk that I want to talk about. Alright, so this set of homeworks, I've given you 10. Chapter 9 and Chapter 10, there's 30 questions. I'm working 10 of them. Alright, so I'm working up a third of the questions for you. Your job is to do the other 2/3. Alright, and they're very similar to the ones I'm talking about right now. Okay, I kind of like looking at it like this. There are 2 types of questions in Chapter 9 and Chapter 10's homeworks. One, there's questions that are very common sense oriented. And then 2, there's questions that require you to use that D over H formula, where you need to think a little harder. So what I'm going to do is I'm going to kind of look at your common sense questions first. And the common sense questions happen to be questions 1, 2, and 3. Alright, so those are your common sense questions. When you see something like that, you don't really have to do a lot of mathematical equations. You can just kind of think it through. Alright, so look at the very first one. It says, the physician writes an order for furosemide, whatever, okay, but it's pronounced, but the common name, the brand name is Lasix. Alright, so the physician writes an order for Lasix, 200 milligrams. Each tablet contains 50 milligrams. How many tablets would you administer for one dose? Well, that's easy. You know you need 200, and you know that one tablet has 50. You can simply say 200 divided by 50 gets you 4. You need 4 tablets. I didn't even have to get a calculator for that. I could do that in my head. It's a very common sense question. 200 divided by 50 equals 4. Alright, now we could create an equation for this, but I'm not. It's not necessary. Okay, it's common sense. Alright, so really you don't even have to have a notes on that one. Just think that one through. Alright, look at question number 2. If one tablet of a certain medicine is to be administered, Q6H. Remember back at the beginning of the module, I told you that Q6H represents every 6 hours. All right, don't forget, because I talked about those in those common abbreviations. So, a tablet is administered every 6 hours for 2 days. How many tablets will be administered in those 2 days? All right, so let's talk about this for just a second. This one we might need to think this one through. One tablet is going to be administered every 6 hours for 2 days. So the question that you have to ask yourself, how many times a day does that patient get a tablet? Well, it says that it's every 6 hours. Well, how many hours are in a day? There are 24 hours in a day. And if you're doing it every 6, you can simply say 24 divided by 6 gives you 4 times a day. So that one person is getting a tablet 4 times a day. That means he's getting 4 tablets a day. Well, what's the question? We want to know 2 days. Well, that's easy enough. 4 times 2, what's that give me? 8 tablets. All right, now yes, that one you had to think just a little bit more on, but it's still common sense. If you know how often they're receiving it a day, and you know how much they need to get in one dose, you can calculate however many pills you need. All right, that one's pretty straightforward. Now this one gets a little bit more, alright? Still relatively easy, but it does take you just a little step farther, alright? It says a doctor ordered 30 milligrams by mouth, that's what PO means, every 4 hours. So I'm going to write this down so I don't forget. 30 milligrams every 4 hours, okay? How many grams will a patient receive in 5 days? So I'm looking at a 5-day spread, and I need to know how many grams. All right, so let's keep this easy first. Let's work our way across. I know that this patient is receiving 30 milligrams every 4 hours. So let's calculate how much that is in just 1 day. All right, well, we know that there's 24 hours in a day. We can divide that by how many hours we're doing, and we find out that that patient is getting it 6 times a day. So 6 times a day that patient receives 30 milligrams. So 30 milligrams 1, 30 milligrams 2, 30 milligrams 3, 4, 5, 6. All right. So I can find out how much they get in a day by saying 30 times 6. So they're getting 180 milligrams a day. But the question asked over 5 days. All right, see how we're just kind of going down a rabbit hole? One thing feeds right into the other. It's common sense, hopefully. All right, so you know it's 180 milligrams a day, and you need to know it for 5 days. So over a 5-day period, you will get, and I'm going to use my calculator now, 180. We're going to multiply that by 5, and we get that the patient gets 900 milligrams. And a lot of people stop right there because this makes sense. You know how much you're getting at 6 times a day, and that gives you 180 a day. They're doing it for 5 days, so it gives you 900 milligrams for that 5-day spread. But there's a problem. Look at the question. The question asks how many grams. It doesn't ask for milligrams. Guess what? Module 1's coming back to haunt you one more time. You have to convert milligrams to grams. Alright, so I'm going to erase this. And I'm going to put this up here. And I'm going to help you out. Where am I starting in my conversion? I'm starting at 900 milligrams. What do I do with it right now? I put a 1 under it. Okay? Now, you need to go find the conversion that will get you from milligrams to grams. I'll wait. Hopefully you found it, and you found out that there was only one. Okay? You should know that it takes, excuse me, 1,000 milligrams to get 1 gram. All right? Now, when you work this all the way out, excuse me, your milligrams cancel and you get 0.9 milligrams. Okay? That's one way of doing it. However, some of you may have found another conversion factor. You may have found this. That 1 milligram is equal to 0.001 gram. You may have saw that. When you do, you work this out, making sure my math is right here. You also get 0.9 milligrams. Now, which conversion factor is right? Well, they're both right. This conversion factor, if you found this particular one, is the same thing as this one. It's just written slightly different. It looks different, but they're not. Okay, they're just slightly different. Okay, so going back to the problem, I knew I had 30 milligrams every 4 hours. That meant that I was getting 80 milligrams a day. I did that for 5 days, so I was getting 900 milligrams over 5 days. But I didn't want milligrams, I wanted grams, so I got 0.9 milligrams. All right, now, that particular problem is the hardest out of all of what I would call the common sense ones. Okay, because it does require you to go back and look at your conversion factors. But the first part of it is pretty straightforward. You just basically multiply. All right, now, this next one is really where I really want you to take some really calm, when you go to do your notes on this, really be very specific. I want you to kind of follow along with what I am doing. It's going to help you. Alright, so first off, before I even look at the problem, I already know what I'm kind of looking at is, well, let's just read the problem first, and we'll talk a little bit more. It says the drug reads Nubain 3 milligrams subcut, which is subcutaneously going under the skin, every 4 hours. And the 20 milliliter multiple dose vial is labeled Nubain 20 milligrams per ml. All right. Injection. How many ml will be giving subcutaneously during 1 day? There was a lot of information thrown at you. And when you see a lot of information like that get thrown at you, you're probably going to use that equation D over H times Q equals X. This is where I want to start talking about it. All right, now, your formula sheet breaks each piece down. D means your desired dose, okay? That's how much you want to give the patient, the actual patient, what you're required to give them. The next thing happens to be the H. I'm going to give me some more space. H. And in your notes, you might want to give yourself some space too, because we're going to fill in some more blanks here in just a second. All right. If you want, wait till I finish all this, then copy it down. So I want you to see everything. All right. So H is amount of active ingredient. I'm running out of room. Okay, I'm going to write that D over H times Q right here. Now, this should sound familiar. That was what we talked about in the last video. We're talking about the strength of the medicine. Okay, Q. It is quantity needed. Okay, this is the quantity needed. How did I word that? Quantity needed to get I'm going to say active ingredient, all right? And then lastly, my X is the amount of the physical medicine I need. Now, your formula sheet goes into some other ways of saying this, but I'm going to break it down just a little bit to explain it. D, that's the desired dose. That's how much medicine the doctor is telling you to give the patient. And that can be based on several key factors. And we'll talk about those in just a second, all right? So that's how much you're supposed to give the patient. However, remember in the last video I told you that sometimes the medicine says, okay, this amount of active ingredient is found in this actual amount of that medicine. Like I believe it was the Tylenol for children, it was 160 milligrams was found in 5 mLs of that vial. It's the same thing. So I need to find the active ingredient, the actual medicine that I'm needing. And then I have to know the quantity of how to get that active ingredient. All right? That's that strength we were talking about last time. I told you it was going to come back to you. And then lastly, X is what we actually give the patient. Just because the doctor says I need to give them 100 milligrams of medicine, I don't just give them, here's 100 milligrams. I might say, hey, here's 2 tablets. Hey, here's 2 milliliters of medication. I'm going to stick this needle in you that has 5 milliliters of liquid in it. And so that's what X is. It's the actual physical representation of the medicine that you are putting in the body. It's not the active ingredient, it's how much the actual tablets are, how much the actual liquid is that's going into that person's body. And that's what we're having to do. Hopefully that makes a little bit of sense. All right, now, there's a little bit more to it. So D, H, Q, and X. However, the desired dose is based on several things, and we talked about this last time too. One, it's based upon the doctor's orders. Okay? The doctor may prescribe something. It's like, okay, give them 100 milligrams. Okay, that's pretty straightforward. Or sometimes the doctor prescribes it based upon the patient's weight, or the patient's BSA. And we did this in the last video, okay, or at least kind of talked about it. We said that the doctor says, we use me for example, I needed 0.1 milligrams of medicine per pound. That was what the doctor ordered. Well, in order for me to calculate the actual dosage that the doctor was telling me to get, I had to take my weight and multiply by the doctor's orders just in order for me to get the dose that the doctor's telling me to do. Alright, so I know that's a lot of information I've just kind of thrown at you, but we're going to work these problems and hopefully you'll see them a little bit easier. Okay, so in order for you to use this equation, you got a lot of information that you're going to have to figure out. Alright, so what I am going to do is we're going to look at each one of these equations and we're going to, not equations, but questions, and fill in the things that we know so we can end up solving for X. So pause the video, kind of write this stuff down so you've got it for your own reference. And when we go back to the question, I'm going to walk you through this. Alright, so pause the video and copy it down. Alright, now, let's go right straight to question 4 now. I've rewritten things so I can kind of fill in the blanks as need be. Question 4, it says the order reads 3 milligrams subcut every 4 hours. The big thing that I really am curious about that is how much medicine I need, not the every 4 hours parts, because the every 4 hours tells you how often to give the dose. The actual medicine, which is 3 milligrams, is how much the dose really is. So the doctor's orders are 3 milligrams of whatever that medication is. So I'm going to write that down. Alright, and then it says, and the 20 ml multiple dose vial is labeled NuMane 20 milligrams per milliliter. Well, in this one it gets a little wordy, but this is what I want you to understand. It's telling you two things. One is telling you how big the vial is. It's saying that the vial is 20 milliliters. That means that there's 20 milliliters of medicine inside that vial. And then two, it's saying this is labeled Nubain 20 milligrams per milliliter. That is the strength of the medicine that you are getting ready to use. Now go back to the last video and think about it. When I said 20 milligrams per ml, that's written like this. 20 milligrams per 1 ml. The 20 milligrams, well, that's my H. My milliliters, that is how much I had to get that 20 milligrams. Okay, so 1 milliliter has 20 milligrams of the medication that my body is needing. Okay, so then the question says, how many mLs do you need to give subcutaneously in 1 day? All right, so we're asking for milliliters, but it's wanting 1 day. We don't need to forget that. And I am going to put this up here because it did say per every 4 hours, okay? So in order to solve this, we got to do two things. One, we need to find out how much 1 dose is, okay? Just 1 dose, all right? And we can do this very simple. We know that the doctor said that there's 3 milligrams of medicine that we need. Okay, so this is the cool part. I've kind of helped you out on this. I've given you the doctor's orders and it just says 3 milligrams. But in this particular one, there's no patient weight and there's no patient BSA. So guess what your desired dose is? It's actually what the doctor told you to, 3 milligrams. So I've got everything I need to know, but there's a couple other things I want to mention. Your D, your desired dose, is in milligrams. Your H is in milligrams. This is not a coincidence, people. Your D and your H will always be the same unit. They will always be the same unit. And your Q and your X will always be your same unit. Okay? It's just because the math works out this way. If at any time your H and your D are two different units, you're going to have to do some conversions to make them the same. Same concept with your Q and X. If at any time that these two are different, you have to do some conversions to make them the same. Alright, but luckily we don't have to do that right now. And since I'm only trying to find out what 1 dose is, okay, because that's what we're going to have to do, we're going to just plug in our numbers. Well, D happens to be 3 milligrams. My H happens to be 20 milligrams. And my Q happens to be 1. Well, now I can just simply multiply this out. I can say 3 divided by 20 times 1. And I find out that 1 dose is 0.15 milliliters. Okay? But the question, what did it really ask? It said, how many would I receive in a day? So this kind of goes back to a little bit of common sense. Alright? So, what do? We know that this is good for 1 dose and we're supposed to give it to them for every 4 hours. Well, how many times a day is that? Well, that's 6 times a day. So what are we going to do? We know that we're getting this 6 times a day, so we can say times 6. What do we get? In 1 day, you give a patient 0.9 milliliters of that medicine. Now, this one was probably a tougher problem to start off with because we were actually having to look at how much was happening in a day, but it's a good one still. First off, find out how much 1 dose is. That's your first priority. How much do you need to do to make 1 proper dose? And then once you know that, you can calculate how much in a day, how much in 3 days, etc., etc. Key points again, all right? First off, your D and your H always have to be the same unit, otherwise you're going to have to do some conversions. Your Q and your X always have to be the same unit, otherwise you have to do conversion. And this format that we're using, the D over H times Q, it is only good for one dose. You're calculating one dose. And anything else that goes beyond one dose, you're going to have to use some common sense. All right, so now I'm going to erase all this information again. Okay? Because I can, you're going to have to write it all down. And I'm going to go on to the next problem. Okay? So, this is 5. It says order fruity. Don't know what that says. Penicillin G potassium. That makes more sense to me. It's asking for 2 million units IM stat. IM is intramuscularly. It's something that's straight into a muscle. Stat means right now. The multiple dose vial reads 5 million units. The manufacturer recommends reconstituting 8.2 milliliters of sterile water to provide a strength of 400,000 units per ml. How many milliliters will you prepare? All right, so let's go through this. It says the order, this is the doctor's orders. It's 2 million units. All right. And then it gives me a bunch of words. It says the multiple dose vial reads 5 million units. Well, that right there is how many units are inside the vial. It's just how big the vial is. It's giving you that measurement. It's kind of like saying that there's 750 pills inside of a box. That's really what that's happening to say. Then it says the manufacturer recommends reconstituting 8.2 mLs of sterile water. All right, pause. Well, no, let's finish this sentence out, then we'll pause. To provide a strength of 4,000 units per ml. Look at what it says at the very end of that sentence. It says to provide a strength. Hey, the strength, 400,000 units over ml. I know my first unit, my first number happens to be my H. And I know that the second, the per ml, is my Q. All right? Now, this is where people just like, there's another number there, Mr. Lewis. What do I do with it? There's 8.2. The 8.2 means nothing to you in this problem. Okay? Sometimes, and I want you to try to explain this, sometimes you get a medicine that is dry, and your job is to add water to it. That's what's happening here. You have a dry medicine, and they're adding water to it. That's what the problem was saying. But the water that you're adding to it doesn't affect any of this. Look at what I've given you. I've given you the doctor's orders. I've given you the H. I've given you the Q. This problem has nothing to do with weight and nothing to do with BSA. There's nothing in there written about it. You've got all the information you need to solve this problem. The 8.2 is just there to tick you off. All right? So somebody's not going to watch this video. And they're like, I don't know what to do with the 8.2. And I'm going to say you should have watched the video. Or at least go back and watch it. I guarantee it. I'd bet money on it. Why? Because that's me. But reiterate, 8.2 in this particular problem is just instructions on how to make the medicine. It has nothing to do with the problem at hand. All right, so going back to it. Since I don't have patient's weight to worry about or the BSA, the doctor's orders are my desired dose. Okay? So before we do anything else, do my units, it happens to say units and units for my D and H, they are the same, so that's good. My ML is the same for both my Q and X, so now I can throw everything in my equation. It's D, which happens to be 2 million, over H, which is 400,000, times 1 ml equals X. Work this out. 2 million, let's see. I can get rid of that. I can get rid of that. Should give me 5. I'll double check. 2 million divided by 400,000 equals 5 mLs. So that patient needs 5 mLs of that actual medicine. Alright, so what I'm going to start doing is I'm going to move on a little faster. I think you're kind of getting the idea of how this works. And again, pause the video, try the next one on your own. I'm not saying pause anymore. And if I do, I'm sorry. Alright. Okay. Order penicillin G procaine 1.3 million units IM stat. You need 1.3 million. Another way of writing 1.3 million happens to be this. 1,300,000. Just to kind of give you a little side lesson, 1.3 million is the same thing as 1,300,000. So if I gave you 2.5 million, it would be 2,500,000. Okay? So that's what's happening here. The 2 represents your 2 million, and then the 3 or the 5 or whatever represents the 100 position. Okay? So 1.3 is 1,300,000. Alright. So that's the doctor's orders, and that's in units. Okay? Then it says the label reads 300,000 units per ml. Hey, since it says that, that's my strength. So 300,000 units is my H per ml, which is my Q. And it's asking then how many mLs do I administer? Well, that's my X. Well, since this problem doesn't give me a weight and it doesn't give me a BSA, I know that my actual dose that I have to give the patient is 1,300,000 units. My D and my H have the same unit. My Q and my X have the same unit. So I plug everything in. My D divided by my H times my Q equals, and we'll do it with you, 1,300,000 divided by 300,000 times 1 gives me 4.3 infinity mLs. Alright, and the problem tells me to round to the nearest tenth, and when I do, that gives me 4.3 mLs. So I have to give that patient 4.3 mLs of that medicine. Alright, number 7. Try it on your own. The prescriber ordered 50 milligrams, okay, 50 milligrams by mouth, that's what PO means, 3 times a day, okay, TID is 3 times a day, for 3 days. Cool. The drug label reads 0.05 grams Yep, 0.050 grams per tablet for 1 tablet. And it's asking me how many tablets will I administer to the patient in 1 dose. So how many tablets will I need for 1 dose? Okay, so listen to what I'm just said here. The last sentence says I'm looking for 1 dose. So do I need to worry about any of this information right here? Because this is going to help me find out how to give medicine over a period of time, but not 1 dose. So really, I don't have to worry with it. And since I don't have anything to do with patient's weight and patient's BA, the only thing I have to worry about is the desired dose, or the 50 milligrams. Cool. Alright, so let's look at what we've got. Our D and our H. D is in milligrams, but my H is in grams. We have a problem. we're going to have to do some conversions because these two will not work. We have to convert. All right, let's take a look at Q and X. They're both in tablets, so that's fine. However, we are going to have to convert one of these. All right, so what I'm going to do, it really doesn't matter which one you convert. You can either convert this one or this one. It doesn't matter. I'm going to convert this, and I'm going to do some scratch work over here. I know this, that I'm going to start with 0.05 grams and I'm going to put a 1 under it, and I am going to multiply that by a conversion factor. You find it. I'll wait. Hopefully you found this, that 1 gram is 1,000 milligrams. We did the same conversion factor at the beginning. Grams cancels out. Let's do the multiplication here. 0.050 times 1,000 gives me 50 milligrams. So my H is actually, I'm going to cross this out, 50 milligrams. Okay, I'm going to erase all this work. So my desired dose is 50. My H is 50. My Q is 1 tablet, so let's find it. Now really, if you've been kind of paying attention, this one you don't have to even do the DH over Q, but let's do it anyway. My D happens to be 50. I need 50 milligrams. My active ingredient is 50 milligrams times 1 tablet. Well, we work all this out. I only need 1 tablet. Now, was it necessary for me to do the D over H times Q in this particular problem? No, not really, because if I understand that I need 50 milligrams, and I understand that 1 tablet is 50 milligrams, why worry? Just give them a tablet. That's all you really need. This one you didn't have to work all the way out, but it's still good practice. All right, so what if I had, I'm not going to do this, it's not the problem. I only asked for 1 dose, but let's say I wanted how much that person would get over 3 days. Well, think it through. The person gets 1 tablet for 1 dose, but it's 3 times a day. That means they're getting 3 doses a day. That's 3 tablets a day. And if it's 3 tablets a day for 3 days, well, 3 times 3 is 9. So for this particular order, that patient needs 9 tablets over 3 days. But that's not what the question was asking. It was only wanting 1 dose. All right. Done with that one? That's therapeutic. All right, 8. The order for, I can't pronounce either one of those words. It is into grilling. I'm into grilling, I like to grill too. I'm into grilling. Somebody in my class is going to laugh at me like he's an idiot if you haven't been laughing at me already. All right, so the order states that I need 100. Oh, this was a tough one. 170. Matter of fact, let's skip 8 right now. Okay, I want to do this one at the end because this one's actually going to for something else. Let's go to number 9, and then we're going to come back to 8. All right, so number 9, it says a physician has ordered Almeta, 500 milligrams per square meter. All right, so that's my order. It's 500 milligrams per square meter. All right. For patients whose body surface area is 2.10 square meters. The medication supplied is 25 milligrams per milliliter, so that's my H and my Q, 25 milligrams, because that's my strength of my active ingredient per 1 ml. How many mLs do I need to administer? All right, now, we got something going on that we haven't been doing before. First off, let's see. what do we know? We know that the doctor is saying that for every square meter of a patient, we need to give them 50 milligrams. All right, so we also know that that patient is 2.10. Go back to the last video. I told you that when you see the doctor's orders say that, bells should be going off that you need to know the patient's BSA. And if you know the doctor's orders and the patient's BSA, which we do in this particular problem, we know both items. In order to calculate the actual dose that you need to give the patient, you have to multiply. So I would say 500 times 2.10, and I get that I need to give this patient 1,050 milligrams of medicine. All right. So all the other problems that we've had up to this point in time, we just whatever the doctor told us to do, we just did it. This time we had to do a little extra math because it gave me the doctor's orders told us for however much space they take up to give them some medicine, and we knew how much space they took up. All right. So now we know this. Now it's pretty straightforward. We know that D and my H, they are the same unit. All right, cool. My Q and my X, they're the same unit. Since all of those check out, we can simply plug everything into our equation. My D is 1050 milligrams over my H, which is 25 milligrams, times my Q, which is 1 milliliters, and then we're going to work this out. 1050 divided by 25 times 1 gets me 42 milliliters. So for this patient, they need 42 milliliters of whatever medication that they're trying to get. Okay? This one's not as bad. Just remember, I gave you two pieces of information, and you had to use both of those pieces in order to calculate just the desired dose. All right? You had to take it a little bit farther. And the way you can remember this is if you see that the doctor's orders are so many milligrams per square meter or per pound or per kilogram, and you are given the patient's weight or the patient's BSA, you're going to have to multiply those numbers. All right, so let's go back to question 8 because this one gets a little bit more involved. And I like this question actually. Hint, hint, nudge, nudge. All right, question 8. The order is for the integralin, all right? And it says that I need 170 micrograms per kilogram IV stat, all right? Intravenously stat. Then it says the manufacturer recommends adding 1 ml of sterile water for injection to each 0.85 milligram vial. All right, pause. That first part of the sentence is just describing how to make the medicine. Just like a problem we did earlier, I've got a vial, it's got dry powder in it. My job is to put water inside of it and then shake it up, and I've created my medicine that I'm going to give the patient. All right? But those numbers don't help us to solve this problem. They're just instructions on making that medicine. All right, so that first part of the sentence is not really useful to us, okay? But this part is. Yielding 0.85 milligrams per ml. That's my strength. So my strength happens to be 0.85 milligrams per 1 ml. All right, how many mLs do you administer? Okay, so we got a couple things happening here. First off, we have the doctor's orders. Oh, wait a minute, I forgot to mention. Here we go. I'm sorry, I skipped the line. It also says that the client weighs 185 pounds. Woo! Wow, we got several things happening here. All right, first off, we already know that I have a doctor's orders and I have the patient's weight. So we're going to have to multiply these two numbers. We know, and so your instinct might be saying 170 times 185. And you're somewhat on the right track because you know you're supposed to take the order because this is per weight, multiply the patient's weight. However, here's the problem. We know the patient's weight in pounds. The doctor prescribed the medicine by kilograms. So module 1's coming back to haunt us. We have to convert 185 pounds to kilograms. All right, now I will tell you this: your module, your module 5 sheet actually gives you a very good conversion factor to find. So find that conversion factor that will get you from, excuse me, pounds to kilograms. All right. So, by the way, notice I've been putting S's there. Technically, in the medical field, it's just LBs, not S. This was the old school way of being taught when I was younger, was LBS for pounds, and it's a hard habit for me to break, so it's just LB. All right, so 185 pounds is where I'm starting. What do I put under it right now? A 1. Okay. Hopefully you found this conversion factor, that you know that 2.2 pounds is equal to 1 kilogram. Okay? Work this out. And let's see, I have 185 divided by 2.2. And we get a weird number. We get 84.0909, etc., etc. That keeps getting repeated. And this is our weight. Now, here's the thing. Your instinct is probably to right now to round this. I am going to tell you no. Try not to round anything until the very end. Okay? So try not to round that. So what are we going to do? Well, here's the thing. It's not as hard as you think. You've already got it in your calculator, but we can do something else to it. So we now know that the patient's weight is at 84.0909 infinity. We know, and it's just in kilograms. So we've done the conversion. It's in our calculator. And we know the doctor's orders is 170 micrograms per kilogram. Well, what do? We're going to multiply those two numbers to find out the actual dose. Alright, so instead of trying to round, just multiply it by the doctor's orders. Plug it in your calculator by hitting times 170. And then what you end up getting is another long number. We're going to say it's 14,295.45 micrograms. Okay? So, in this particular one, we got a little bit of another issue. Can you find out what it is? Well, notice, we found our dosage that we needed, but the dosage and my H, those two units, don't match. So we got another conversion to do. Alright, so, I am actually going to do a little rounding on this step. Let's round this to the nearest tenth, okay? And when we do, we get that. That's pretty straightforward. So we need 14,295.5 micrograms, okay? But the dosage comes in 8.5 milligrams. All right, so which one are we going to convert? It doesn't really matter, but I'm going to have to convert one of these to make it look like the other. I'm actually going to convert this one. Okay, I'm going to convert this one. So I'm going to erase this, and I need to convert 0.85 milligrams. I'm going to put a 1 under it, and I'm going to multiply by conversion factor. Find the conversion factor. Hopefully you found that 1 milligram is 1,000 micrograms. Work this out, 0.85 times 1,000 gives you 850. All right, and that's going to be micrograms. So I can cross that out and change that to 850 micrograms. All right, now what do I have? Well, I've got that my desired doses in micrograms. I have my active ingredient at 850 micrograms, so they're the same unit. My Q and my X are at the same unit. Now that they're all at the same unit, I can actually do my equation. My D is 14,295.5 micrograms divided by 850 micrograms times 1 ml. And when it's equal to my X, work this all the way out, I get that I have 17.869 blah 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 mLs, but the problem told me to round to the nearest tenth. So I should get about 17.9 mLs of that medicine. Wow. I have to admit, this is probably the toughest problem that you will see. I don't think I got anything quite this involved in your homeworks and your tests, but this is a really good one because it takes all your skills. Literally, this one question took all your skills from Module 5 and Module 1 and summed it up quite nicely. 1, you had to know how to convert, and 2, you need to know how to find your actual how to administer the medicine. And also, it took some reading skills because not everything that was inside that question was useful. All right, so going back over the question one more time. 1, we knew the doctor's orders. 2, we knew the patient's weight, but we had to convert the patient's weight into kilograms. In doing so, we were able to find out how much the patient weighed, multiply that by the doctor's orders to get how many, what our actual desired dose was. However, our desired dose and our active ingredients, they did not have the same units, so we had to do another conversion to get them into the same units. Once we did that, we were able to plug it in our D over H times Q. All right. Wow. That was a lot of work. We have one more question. And you'll probably thank me because after this one, your head's probably hurting. Okay? So, let's just look at it. The order is for the I'm just going to say Loporido. Alright? I don't know how to pronounce those, and I apologize. And this one is very interesting. If you look at it, it says that it has Lopo/Rido, and then it's got 240 milligrams/60. This is a strength, yes, but it's not quite what you're used to. This is actually 2 medicines rolled into one. In other words, that this particular medicine, if you look at it, it's kind of interesting. If you look at it, this Lopo represents 80. So there is 80 milligrams of Lopo in just 1 milliliter. But at the same time, there is 20 milligrams of the Rido in that exact same milliliter. So altogether, there's 80 Lopos, 20 Ridos, and they're combined together to make that 1 milliliter. All right? Hopefully that makes sense. So there's 2 medicines happening at the same time. The problem is showing me that I need 240. Well, think this through. 80 times what number gets you 240? 3. 2 times 60 gets you what number? 20 times what number gets you 60? 3. What am I trying to tell you? The answer to this problem is that you need only 3 milliliters of medicine to get this desired dosage of both the Lopo and the Rido. All right? So the answer for this one is a very common sense. You just have to walk it through it. Hey, I only need 3 milliliters. There was no need to do any of the hard work that we just tried to do on this particular problem. All right? So I wanted to end with that problem because it was pretty straightforward. you only need 3 mLs. And that 3 mLs gives you both the 240 milligrams of the lipo or lipo, and it also gives you the 60 milligrams of the Rid-O that you need. All right. All right. Well, that was fun. All right, guys, we're done. This was the last video. I am not recording anymore. Do you hear me? I am not making another video that you have to watch as a lecture. It's not happening. No more lecture videos. I'm done. I'm sick of making them, and you're sick of watching them. So congratulations. You have completed all the material for the entire semester. Okay? All you have left to do at this point in time is to take your Module 5 test and turn a lab in, and finally your final exam, and don't forget your normal homeworks. But that's it. You are right there at the end. So hopefully you have enjoyed the semester with me. You've enjoyed the videos. I try to make them at least a little bit more entertaining than the normal boring lecture. And if you didn't enjoy them, well, tough. I really don't care. You still had to watch them. All right, and we're done. Congratulations, you've made it to the end of the semester, and I will not see you next time because I'm not making any more videos. So